and it's not. There we go. Do you see how this product rule, x to the a times x to the b, is different than the power rule, which is x to the a to the b? What's different? There's parentheses. There's one less of what? Not step. What's missing here that was here? A dot. What else? An x. There's one less x here, okay? So just notice that. Up here, you had two of that same base being taken to different powers. Not necessarily different. They don't have to be different powers, but both of those bases are taken to a power. We call this number, this bottom, the x, the base, okay? So you had two bases and you had two exponents. On the power rule, you have one base, but two exponents, okay? These two, so I feel like it was tricky between 6-1a and 6-1b, like when do I add, when do I multiply, what am I doing with my exponents? Today is another level of tricky because now you have multiplication, okay? But what's happening is we're taking some monomial, x to the a, and we're taking it to a power. What does it mean to take something to a power? What is that telling us? Like if I say x to the second power, what does that equal? X times x. X times itself, okay? So if I take x to the second power and I take that to the second power, think about what that's saying. It's saying x squared times x squared, which is x to the fourth, okay? Because that's essentially x times x times x times x. So I think what you need to try to train your brain to do on these is think about what does that mean? Not just what's the rule, but what does it mean in this situation? Because if you can figure out what it means, then you can usually figure out what rule is applied to it, okay? So think about it this way. If I have x to the a times x to the b, that's x to the a plus b. But if I have, let me get all this junk out of here, x to the a power, and I take that to another power, what ends up happening is you multiply your exponents now. So up here you were adding them. Now you're going to go x to the a times b. So a power to a power, you multiply the powers. A power to a power, multiply the powers. Say that in your head a bunch of times. A power to a power, you multiply the powers. Okay? Maybe you want to write that down. A power to a power, you multiply the powers. Okay? A power to a power, you multiply the powers. All right. Are you ready to try some? So if I say x squared, and I'm taking that to the x, or to the 8th power, essentially what that means is this, and you don't necessarily need to write this down if you don't want to, but I want you to understand it. I'm saying x squared times 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 1, 2, 3, 4, 5, 6, 7 times x squared, right? I'm taking x squared times itself 8 times. But when you multiply like this, that's the product rule. That's where you add all your exponents, which is really saying x to what power? 2, 4, 6, 8, 10, 12, 14, 16, right? If we added them all together, it's x to the 16th power. Well, rather than have to do this every time, when it's a power to a power, you multiply the powers. So 2 times 8 is 16. So this is x to the 16th power. Okay? This one's a little bit trickier. Now you have m to the nth times n to the 5th, all taken to the 4th power. What do you do with that? M to what power?
4, 9, 2, 9.
What do you do with the 4 and the 9? You're going to multiply. You're going to multiply this. So 9 times 4 is 36. So n to what power? The 20th. You're going to multiply those powers. So if it's outside of the parentheses, it's kind of like the distributive property in that you want to do it to every exponent. Okay, if it's outside the parentheses. If it's inside the parentheses, it only applies to the number that it's attached to. Okay. Okay, so look at number 3. PQ to the 5th in parentheses taken to the 3rd power. That becomes P to what power?
P to the 3rd.
P to the 3rd, because that's like P to the 1st times the 3 is P to the 3rd. And then Q to what power?
15.
The 15th. Okay, when it's a power to a power, you multiply the powers. Okay. Questions on that? Okay, here's where it gets a little hairy. Because now it's not just variables taken to powers. Now we're going to throw some coefficients in. What's a coefficient? A number out in front of a variable. Okay, so if I'm going to raise a coefficient to the given power, I'm essentially saying take that number to that power. Okay, and then you'll simplify the variables with the power rule. So just like we did before, when it was multiplication, we multiplied those numbers out in front, and then we did what we needed to do separate to the exponents. That's the same here. We're going to take 5x to the 7th to the 2nd power. So essentially we're saying 5x to the 7th times 5x to the 7th, right? We're squaring it. We're multiplying it by itself. Well, when I multiply like this is the product rule. I would multiply my coefficients, that's 25, and I would add my exponents, x to the 14th. Okay, so if you want to turn it into the product rule every time and do it that way, you totally can, but it's a lot of work to do it that way when this number is a big number. So I don't recommend you do that, but if it helps you just to think through it, then go for it. Okay, what I would say is just remember the idea that when it's in parentheses and there's a power, you are going to take that power to everything. And I think where most people are going to make the mistake is they're going to try to turn this number into a 10. Why do I think that? Because 5 times 2. But it's not 5 times 2. It's 5 to the 2nd power. And it's x to the 7th to the 2nd power. Okay, so just remember this is a power. It's an exponent. So use it as an exponent when you're working with the coefficient. Okay, so 25 x to the 14th. Okay, look here. What's the first thing I'm going to write down if I'm solving this?
5 going into
Not
again 25.
what? Not 25, because it's not 5 to the 2nd power. It's what? 2 to the 5th power. Do you know how to plug powers into your calculator?
Yeah.
Because that's a pretty big number to do in your head. You're going to go 2, and then is yours a caret key? Can I see that real quick, Kiana? Yeah. Okay, so on the left side of your calculator, you have this little key. Okay? You're going to hit 2, the caret. This is called the caret, and then a 5. So go 2 caret 5. What do you get? What is it? 32. So 2 to the 5th. X to what power?
10.
What'd you say?
Well, I said 10.
10. X to the 10th power, right? You multiply those, 2 times 5. And then y to what power? There's a 1 there, right? 1 times 5 would be y to the 5th power. Okay, this is great, but it's not the best because 2 to the 5th can be simplified to 32. So your best answer here is that. Yeah.
Wouldn't be wrong if it's not simplified.
Yeah. I mean, you get like a half a point off.
Yeah.
Yeah.
I was confused for a second. I thought you were all Like it's x squared.
Like on the x squared to the 5th, you were gonna take, like, so x to the 32nd, you're saying? Yeah. Yep, be careful with that. Who said my name? Yeah. Oh, you maybe have, do you have this key?
Yes.
Yeah, it'll be that one. So go 2 and then that key and then 5.
Okay, there you
Okay. Okay, this one is a little bit trickier because there's that negative there. And this one gets plugged in wrong all the time. My Algebra 2 students just took a test. A bunch of them plugged this in wrong. And this is just to plug it in the right way. You can do this. I believe in you. You're going to take everything to what power? The second. Everything to the second power. So here's what you have to do on this. If you plug this into your calculator's going to lie to you, but it doesn't think it's lying to you. But it thinks you're saying, what's the opposite of 8 squared? That's not what we're trying to do. We're trying to say, what's the opposite of 8 squared? Okay? Do you hear the difference in that? So put parentheses around the -8 and then square it. What do you get? A positive 64. So just be careful with that. All right, then we get c to what power?
To the 16th.
Not 16th.
Oh, to the 8th.
To the 8th, yep. Multiply those, 4 times 2. So c to the 8th. And then d to the 18th. Multiply those. That's your final answer. Okay? Let's do, you do number 8. Try number 8 right now.
So, I did the -5 to the 4th power. You're supposed to do that, right?
Mm-hmm.
I got -625.
Yeah, because you didn't do what I told you to do.
Oh, parentheses.
Parentheses.
Oh.
It should be positive. But you can have a big number like that. That's why we love the calculator, right? It's going to find the big number for you. Yeah, but it should be positive. Okay. Which one were you looking at? Oh, you were doing 7?
8? Yeah, 7.
You did 7.
I did 7.
We're doing 8, but that's okay. 8's a good, or 7's a good one too. What did you get for your answer? -27. X to what power? X to the 6th power. So here's the thing. We still want parentheses, -3 to the 3rd power. Why does this one stay negative? Because a negative times a negative times a negative, right? There's 3 of them. That's going to be a negative answer. It's when it's a 2 or a 4. If your exponent is even, you should never have a negative number there. Okay? Because negative times a negative will always be a positive. So this is number 8. Good?
Yeah.
Wait, how did you get the 6? I got 8 instead.
How did you get 8?
3 times 2?
I did 2 to the 3rd power.
Oh yeah, don't take it to that power. You multiply the exponents.
Oh,
So you go
if
2
there's-
times 3.
If there's like a big number next to the x, you only do like -3 to the 3rd power. And
You
then
take this one to the
x.
power. If it's a number, the like,
Yeah,
yes, a big number here
and then
gets
the
taken to
x-
the power.
And the x of the numbers, you just
You
times.
multiply them. Yep. Yeah. Okay. Do this for me. Try. Try 10 and 13 and 14. Okay, try those 3. If you want to talk it over with a person nearby, that's great. If you want to do it on your own, that's fine too. But give those 3 a try, and we'll see how it goes.
Hello.
Then we're done. Okay.
Who's done with all three of them?
I don't know
Not
about
quite?
that.
Okay. Keep going. Oh, why are so many of you offline?
Cool. What did you get something to? I feel like I supposed to just like these 50 to do that and then I'll just right here. Or leave that because
Work that one out.
she might have it next year.
I know, work it out. You're supposed to be trying.
Oh,
Caleb, make sure you take the 2 to the power 2. Will you guys make sure your Wi-Fi's on? There's like 5 of you that are offline right now. Turn your Wi-Fi on.
am I right? Or is there something I did wrong?
I did it. Did you get X?
So see your A's, a to the 4th and a squared. Because you're multiplying, you can combine those. So that would be 3a to the 6th.
Well, technically, because there's no number next to the A, what does it be for? A, and then 4 times?
Oh, wait, no.
No, because it's not saying, it. Which one is this? 14. It's not a to the 4th to the 2nd. It's a to the 4th
Oh.
times a to the 2nd. So then you add them
Okay, so it would just be 3A6.
to the 6th.
Okay.
And then look at, now you have like terms. So now you can add them together.
Yeah.
So when it comes to like
So you were right.
1, nice. I'm getting it 1 9. So it's just 1 9. Or can it be simple?
Which one? Are you looking at this?
Yeah.
So type in, where are you getting 1 9?
Doing this twice. 1/3 twice. 1/3 times.
Oh, you're squaring 1/3.
Yeah.
So you're trying to figure out, I guess I'm not sure what you're asking then. So 1/3, I would plug it in like this. I would go on your calculator, put your calculator up here real fast. So go in parentheses 1/3 and then square it. Right?
Yeah, it's 1
So
9.
that's just it.
So it's just 1 9.
Yeah. I mean, but then you're gonna multiply it by what this comes out to too.
Oh wait, 14 AD. Okay.
You said to add them right after, so.
That's good, except for these are like terms. When you add, you gotta keep your like term. This is like saying 8 apples.
So it's
plus
still
3
A6.
apples. Yes, is
Oh, I have an
11,
A6.
8 to the 6.
Okay.
Yep. Okay, let's look at number 10. Yeah. Some of you are mixing up how you're doing this, okay? This is x to the 3rd, y to the 3rd, but that whole thing is being taken to the 3rd power, okay? A power to a power, you what? Multiply the powers, okay? So when you take a power to a power, you multiply them. So this is going to be x to the 9th, y to what? The 9th, times x, y to the 2nd. Now you have the same base. So this is x to the 9th times x to the 1st. When they're the same base, so it's not a power to a power anymore. So don't multiply them now. What do you do with them? You add them. X to the 10th, y to the 11th. And that's as simple as you can go. You can't combine your x and y because those are different. So you just leave it like that. Does that make sense? How do, the y exponents, you add those together. Okay, go to number 13. I know you're used to going, oh, here's a 6 and here's a 1/3, let's multiply them. But what does PEMDAS say first? Parentheses, okay? Is there anything you can simplify inside these parentheses right now? No. These parentheses, no. What's next? What does E stand for? Your exponents. You have to do your exponents next, and then you can multiply and divide, okay? So we're going to first do this. What does that 6 become? It's not 18, but a lot of you are going to want to do that. That is the most common mistake. You take the 6 to the third, what is it? 216? So that's 216. 6 to the third power. What does this A become?
A6.
A to the 6th power. You're going to multiply those. B to what power?
B3.
To the third power. Okay? So that's your first part. Now we're going to multiply, and now you have to distribute this 2.
1/9.
1/3 to the second power is 1/9. If you're still not sure how to plug that into your calculator, talk to me. Then we have 3 different variables here,
ABC2.
and they all have to get taken to the second power. So A squared, B squared, C squared. What's your next move? You're gonna multiply 216 and 1/9, okay? So plug it into your calculator and plug this in right now. Make sure you know how to do this because some people just don't know how to plug it in. 216 times, and then type in 1/9, and you should be getting 24. Is anyone not getting 24 when you do that? So you're gonna go 216 times 1 ABC 9. Okay. So that comes out to 24. What do you get A to the 6 times A squared? Do you add those or multiply those? You add them. They both have the base. When they both have the base, you add them together. A to the 8th. B to what power?
B to the
5th. You add them, okay? And then C to the 2nd, and you're done. Okay? Okay, last one. You have 2 to the third and A squared to the third. What's 2 to the third?
I have a question for the last one.
Yeah.
How did you get C2 if there's no
16.
There's a C here, and it was taken to the second power there.
Yeah, but the one on the left, the A6, B2, there's no C.
Right, so if there's nothing there, then there's nothing to multiply this by, so you just leave it as is. Yeah.
2 over 2, that's not right.
Okay, 2 to the third power, that's 8. A to what power? A power to a power, you multiply the powers. So that's 6 plus, this is A to the 4th times A squared. What does that become? A to the 6th. You add them together. This isn't a power to a power anymore, right? This is 2 separate bases. So 3 times A to the 6th power. What do you do when you add with those variables? What does this become?
11A6.
Yes, 11, but these are like terms. Keep those like terms. So that would be 11 A to the 6th. Okay? Questions on any of that? So, like from this, or how did I get even to this point?
Yeah.
To that point. Okay, so I had 2A squared, and I'm taking it to the third power. So I got to take the 2 to the third power, and I have to take the A squared to the third power. So 2 to the third power, that's the 8. A squared to the third power, you multiply. So you get A to the 6th. Okay? This one, you have a to the fourth times a squared times 3. So you're just going to put that 3 out in front because the number in front here was a 1. So that doesn't change the big number. But a to the fourth and a squared, now they both have, so notice this was a power to a power, so we multiplied them. But this is, they both have the same base, so we add them, right? So a to the sixth for that. And now you can combine. So 8 plus 3 is 11. But your a to the sixth is going to stay a to the sixth. If they both have a base, add the exponent. Yes. Yep.